Chapter 7, Similar Polygons. Today we're going to cover section 7.4, a postulate for similar triangles. The class opener. The measures of the angles of a pentagon are in the ratio of 5 to 7 to 8 to 4 to 3. Find the measure of each angle. Our objectives for today dealing with the similar triangles. The first one is use the angle-angle similarity postulate to prove triangles are similar. And the second one, use similar triangles to deduce information about segments or angles. Okay. So angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Directions. Tell whether the triangles are similar or not similar. If you can't reach a conclusion, write no conclusion or not possible. So looking at number one, right off the bat I see parallel lines. And I know that parallel lines corresponding angles are congruent. So there's the small triangle at the top and the larger triangle. They both have two angles congruent, so they would be similar. Number two, I know that I need two angles to match up, and currently if I look, they each have a 40-degree angle. I see 110 and 30, but I don't know the other values. So what I would do is come in here and let's figure out how big this angle is. I know all three angles in a triangle have to add up to 180. So if I take 180, subtract off 110, and subtract off 140, and let's see what's left. So that should give me 30. And now it's enough for me to look that the two triangles have two angles that are congruent. So this is going to be similar by the angle-angle similarity. Number three. So I do see that I have a 38-degree angle. It looks like this other angle over here might be 90 degrees, but I don't know. So that's it. So all I know is they each have a 38-degree angle, so this is no conclusion. Let's look at the next one. I see that I have isosceles triangles. So I know that this is a 70 and a 70. But now let's figure out. Well, if I know these two are 70, I should be able to figure out that the one up at the top would be 180 minus those two. So 180 minus 140 would leave me with 40. And now I can tell that the triangle on the right has a 30-degree angle. There are no 30-degree angles on the left, so this one is definitely not similar. Okay. Directions. Find the values of x and y. So the big thing here is they didn't tell me that they're similar triangles, but I do know that corresponding angles are congruent. So I do know that the smaller triangle is going to be similar to the larger triangle, so I can set up proportions and cross multiply everything. And in looking, I sort of noticed that the 4 in the smaller triangle is going to correspond to a value of 7 in the larger triangle. So I'm going to be using that for my scale factor. And now I'm just going to set up a proportion between all of the other sides as well. So if I start to set that up, I notice that 3 in the small triangle is going to match up to x plus 3 in the larger one. So let's fill that in. And then if I look at the last side up here, I know that y in the small triangle is going to correspond to 8 in the big triangle. And now I'm just going to set up proportions and cross multiply. So again, picking my scale factor of 4/7, and I'm only going to look at the next part, which is 3 over x plus 3, and let's cross multiply. So I'm going to start by distributing the 4 in, get 4x plus 12, and if I cross multiply I get 7 times 3, which is 21, and let's solve this equation. So I'm going to subtract the 12 off of each side, so I get 4x on the left, I get 9 on the right, divide by 4, I get 9/4, and you can go to a mixed number if you'd like. Okay. So I have my value for x. Now trying to figure out my value for y. Well, now when I cross multiply, I'm still going to pick my scale factor of 4/7, but I'm going to cross multiply it with y over 8. So 7 times y gives me 7y. 4 times 8 is 32. Divide each side by 7, and 32 doesn't reduce with 7, so I could just leave it as 32/7, or I could always go to an improper fraction if I wanted to. Given that segment AB is perpendicular to BF, I'm going to start to write this in. So AB is perpendicular to BF. RH is perpendicular to AF. Angle 1 is congruent to angle 2. They want me to prove that HR times BF equals BA times HA. Right. So let's write down our statements and reasons and then get an idea of what's actually happening. So filling in our statement, so we're just going to copy the given information. We know AB is perpendicular to BF. I know that RH was perpendicular to AF. And I know that angle 1 is congruent to angle 2. And I know that was all given. Well, looking up here, I see that the two triangles are going to end up being similar by angle. If the triangles are similar, the sides should be proportional, and if I go to multiply a proportion, I would get the statement that I'm trying to have proved. So let's start to fill through. So I want to state that the triangles are going to be similar. I already know angle 1 is congruent to angle 2. The other two angles, I don't have them congruent yet, I just have that they are perpendicular. So let's state that the perpendicular lines form right angles, and then that the right angles are congruent. So I'm going to make my life a little bit easier and just call this angle 3 and angle 4. So angle 3 and angle 4 are right angles, and the reason is going to be definition of perpendicular lines. Now I'm going to state that angle 3 is congruent to angle 4, and the reason would be right angles are congruent. Okay. Now that I have two angles congruent in the two triangles, I can actually state that they are similar to each other, and I just need to make sure I name them appropriately. So the little triangle, I'm going to call triangle RHA. State that it's similar to the other triangle, and I notice that angle 1 should correspond to angle 2, so naming the other one I should have A. Then I went to H, which is the right angle, so that's going to be B in the other triangle, and then eventually F. And the reason is going to be angle-angle similarity. Well, I know if triangles are similar, that the sides are proportional. So let's set up my proportion. So I'm just going to pick the triangle over here. The first side here is RH. Should be proportional to HA. And I'm just getting that by picking the first two letters and the last two letters. And I know that this should be the same as in the other triangle if I pick the first two letters AB over the next two letters, which is BF. And my reason would be if triangles are similar, then sides are proportional. And now if I just pretty much cross multiply this proportion I have, okay, so if I cross multiply, imagine I'm multiplying this way. I'm going to have RH times BF, which is pretty much my proof statement, except for instead of RH, it's HR, so I'm going to switch it around because it's really the same thing. So HR times BF is going to equal, and then I look, if I were to cross multiply the other direction, I'd have HA times AB, which is pretty much exactly what they want in my proof statement, except for the order is reversed, but I'll just rewrite it the way they want in my proof statement, which is BA times HA. And I'm really just cross multiplying, which was the means equal the extremes. And there's my final statement. Number 7, Tom wanted to measure the height of a tall tree. He knew he was 6 feet tall and measured his shadow to be 4 feet long. How tall is the tree if its shadow is 18 feet? I tend to just think of this as really simple. Here's Tom. He is 6 feet tall. His shadow on the ground is 4 feet long. And imagine making a triangle. Same thing should happen for a tree. If the tree has a shadow of 18, and I want to figure out how tall it is, well, if you did this at the same time of the day, they'd be similar triangles, so you should be able to set up a proportion. I'm just going to set up a simple proportion of height over shadow. So if I do that for Tom, he has a height of 6 over a shadow of 4. And for the tree, the height I don't know, and the shadow is 18. Reducing right off the bat on the left side, I can reduce this to 3/2. And now let's just cross multiply. So 2 times x is 2x equals 3 times 18, which is 54. Divide by 2, and I get 27. So the tree is 27 feet tall. And your closure. I knew I was right when